Thank you so much. Welcome everyone to Data Toboggan 2022. As you guys know, my session is based on building end-to-end modern data warehouse with Azure Synapse. By the way, thank you so much for sharing your valuable time, and thanks to all the organizers for the opportunity. Who am I? I am Jean-Joseph. I've been in IT for over 19 years. I started as a network administrator. Then after that, I moved to database administration and development. After that, I moved to data engineering. I'm located in New Jersey, originally from Haiti. I am the founder and main organizer of data-driven community. Under data-driven community, we have cloud data-driven and feature data-driven, and also IT management and leadership. So if you guys want to email me, feel free. If you want to connect with my community, this is the code that you can scan. If you want to connect with me on LinkedIn, this is it. If you want to follow me on Twitter, that's me right there. So that's been enough about me. Today, this is our overview. I'm going to talk about modern data warehouse prerequisites, and we're going to revisit the cloud data warehouse solutions, and then I will introduce Azure Synapse architecture. We're going to compare it with the normal way we done cloud data-driven warehouse versus Azure Synapse solutions. Then we're going to talk about the main topic, which is the data modeling, the distribution, and the data processing. First of all, before we start building our end-to-end data warehouse, we need to find out exactly what business want to achieve. Okay, the kind of questions business will ask. Can our data answer those questions before you start designing any giant data warehouse, right? The first step is to identify all the necessary steps to centralize and connect all your data. Once you identify them, you have to outline the key technical requirement for analytical grade data warehouse. And then the third one is you have to select the right data platform approach for your business. And then this is where things get a little bit tricky sometimes. Okay, so now let us revisit the normal way we build cloud data-driven warehouse. First of all, before we build it, there's a tons of issues we may face. The first one is what we call data silo. Data silo is that, for example, is a collection of data held by one group that is not easily or fully accessible by other groups in the same organizations, right? So that's mean that can increase your delivery time. But however, let's say if we bypass that, we're able to get the data, like we know the type of data. Is it relational, IoT, unstructured, semi-structured? Do we have to collect the data from other Azure services or other services outside of Azure, like on your own prem data center, or even from other cloud provider like AWS, Google? So once you identify them, that's when you're gonna find a way to ingest your data. Doing the ingestion and processing, that's when you're gonna think of Azure, for example, Data Factory. That's gonna go, that can maintain your ingestion for you and do the processing, right? And then if you're dealing with big data, that's when you're gonna think, for example, of Spark, right? So once you process, once you ingest and processing your data, you will need to store your data. You can store it in your data warehouse, what we call, for example, Azure Synapse SQL pool, or you can store it in your data lake. So once you store it, that's when people will come, like do some machine learning, Power BI, do all kind of transaction. As you can see, the complexity is there is absolutely no way you can centralize all services. Sometimes each one maintained by a different team and costs matter. So what exactly Microsoft did? Microsoft came up with Azure Synapse Analytics as a limitless analytics services that brings together data integration, enterprise data warehouse, and big data analytics, right? So with the help of one interface that called Azure Synapse Studio. So once you access your Azure Synapse Studio, connect your Azure Workspace account. Under that, you have access, for example, to query the data from your data lake with a common data model, enterprise security, and optimized for analytical. And then it is designed for analytic workloads at any scale. It doesn't matter if you are doing artificial intelligence, machine learning, Internet of Things, intelligent apps, or business intelligence, you can do it at any scale. What I like about it, it is user-friendly. It is built for developers' experiences, for code free or code first. So that means if you are a designer first, you don't know how to code, you can leverage Microsoft Azure Synapse Analytics today. As long as you know exactly for each activities what they do, you can start building your data pipeline. And if you are a scripting guys, Azure Synapse support multiple languages that suit to different analytic workloads. Like it doesn't matter if you come from a SQL background like me, you can use SQL. You come from a Python background, you can use Python, .NET, Java, Scala, and R. What I like about Azure Synapse is that it came with two types of integrated analytic runtime. The first one is provision, and the second one is serverless. Provisions is what used to be, for example, Azure SQL TW. It is a reserved instance. It comes with, for example, a distributed system where it is it's decoupled. For example, the compute from the storage. You can pause the compute and pay for storage, and then when you need the compute, you can resume it. And then it allows you to build your physical data warehouse. The next one is for example, the serverless. Serverless allow you to query data, for example, from your data lake storage with the help of the familiar TCO open reset functions. There are tons of useful features like automatic schema inference that allow you to repackage files without having to declare colon name in your queries. What I like about this, there are some applications that rely on CSV file only, right? You can leverage serverless pool to create a logical data warehouse. And then the good thing is it is cost effective because you only pay for what you use. And then for every 1 terabyte a query processing, there's gonna be a cost for $5. However, if you think of performance, it may not give you the exact performance that you wanted, but it can resolve a tons of issues. And then the analytical runtime supports SQL and Spark. So you can leverage SQL to design very complex batch, streaming, and interactive processing. Or when it comes to, for example, to big data, you can leverage Spark to design, any big data processing when it comes with the help of Python, Scala, R, and .NET. It's also integrated with other services, right? Like management, security, monitoring, and MetaStore integration, Power BI. As you can see, if you're looking at from your Azure Synapse workspace, you can link it to Data Factory to do your ingestions and processing. You can leverage Power BI to do, for example, your visualizations. You can leverage Azure Purview when it comes to data governance, linear and classification. You can use machine learning and Azure Cosmos DB. What I like about this when it comes to security, you have a tons of features available like Azure Data, Azure Active Directory, Key Vault, Security Center policy, and you can monitor it as well. You can even monitor the cost admin as well. And then it is integrated with GitHub. So if you're looking at this, what exactly, what kind of solution Azure Synapse brought to us is that it's brought all those services as a single source of truth. For example, it provides team collaboration, like data scientists can work together with data analysis, DevOps and data engineering, data consumer. We all can work together. So that's one of the things that make Azure Synapse Analytics very powerful. So let's explore the Azure Synapse a little bit. If you're looking at here, when you connect to your workspace, so you can see right there, they give you, what you can do. If you want to ingest, you can start from here. If you want to explore your data to get inside, you can start from here. If you want to visualize, you can leverage the capability of Power BI to build interactive report. If you click on New right here, you can get access to script, even notebooks if you want data flow, Apache Spark job definition pipeline. And then this is the developer hub. You have access to your home space of Azure Synapse workspace. If I click on develop, you will see it is the same interface as you can see, right? Let's say if you want to explore our data, we click on data, you can clearly see, the data. If I want to go deeper, that main actions. If I want to see what kind of link, or if I want to link to SQL Server, to Azure Cosmos DB, I can click here. I can link to my storage. I can see all my link, okay? And then if I want to go and do some complex operation, designing some data pipeline, I can click here on integration, on integrate. The integrate, this is the interface. I can see the data pipeline that I have. If I want to create a new data pipeline, I can click here, and then it's gonna give me access to create a new pipeline. And then I can copy data, I can import resources from support file, and I can browse. Let's say if I don't know Azure, if I don't know what to do, I can go and check to see if there is a sample and see how they've done it, and then replicate it. I can also import from a pipeline template. If I want to modify an existing pipeline, I can go back to my pipeline and click on it. You're going to see the 3 dots. If I click on that 3 dots, which is action, I can open, I can monitor it. As you can see, monitor here as well. I can clone it, I can rename it, I can move it, I can download support files, and I can also delete it. Let's say if I want to open it, I can click on open. When I click on open, that's when you're gonna see, for example, how capable Azure Synapse Analytics is. You can create notebooks under Azure Synapse. I can add these activities. I can add a Spark job definition. I can add a SQL pool store procedure. I can also transform data with the help of copy data and data flow if I want to do fine-grained data processing. And then I can analyze. I can use Azure Data Explorer. I can do Azure Functions. I can use it, batch services, Databricks. And when if I'm dealing with big data, it would be best to leverage Spark. I can have a Spark notebook, Jar, and Python. I can do data lake analysis, as you can see here. For general, it's like, for example, if you want to get the metadata, if you want to delete, if you want to do kind of complex, very individual operation, general, most likely we have activities for that for you. I can, if I want to interact with MapReduce, for example, Hive-Peak, I can leverage HD Insight right from my Azure Synapse. I can also do iteration and conditional and even do machine learning. Right. So now this is, guys, for Azure Synapse. Let's go to our main topic. When it comes to designing a data warehouse, it is highly recommended to go with these three requirements. After you get the information from business and you validate the question the business want to ask, the data have those answers. So now you once you get those information, that's when you the business requirement and the application functionalities will tell you exactly how to design your data modeling. And then the distributions, because you're dealing with a distributed system, you have to think of access pattern if you want to optimize for example performance, right? So, and then you have to think of the data processing pattern. Let's start with data modeling. In a data warehouse, correct, guys, a schema is used to define the way to organize the system with all the database entities like fact and dimension tables and their logical association. So that means you cannot start building your data warehouse without knowing exactly what schema will you go. Should you go, for example, with star schema? When it comes to star schema, you have to think of denormalize. Your data has to be denormalized. It is the simplest and most effective schema in a data warehouse. The fact table maintains one-to-many relationship with all the dimension tables. Navigation among the table in this model is easy for querying aggregated data. And what I like about this is that end user can easily understand this structure. Query use very simple join while retrieving the data, and thereby query performance is increased. It is simple to retrieve data for reporting at any point of time for any period. But if there will be a tons of modification in the requirement, therefore a star schema is not recommended to modify and reuse in the long run. So that's been knowing exactly how business will use that and how you're gonna lay out the type of transaction. It's gonna help you define your schema. So if you're looking at for Snowflake schema is that you can see here there is a star schema that act as an input to design a Snowflake schema. Snowflaking is a process that completely normalizes all the dimension table, form a star schema. The arrangement of a fact table in the center, as you can see right there, right? Surrounded by multiple hierarchies of dimension table look like a snowflake, as you can see. Every fact table row is associated with its dimension table row with a foreign key. What I like about this is that data redundancy is completely removed by creating new dimension table. When compared with star schema, you can see there is less storage being used, and it's easy to update and maintain the Snowflake schema. The downside of this schema is that due to normalized dimension table, the ETL process has to load all related tables. Hence, performance will impact because of the query complexity, as you can see, right? You can see if I want to access, for example, some information, so there's gonna be tons of join. So there is, for example, Galaxy schema. Galaxy schema, also known as a constellation schema. In this schema, multiple fact tables share the same dimension table. The arrangement of fact table and dimension table look like a collection of stars in the galaxy schema model. The shared dimension in this model are known as conforming dimension. This type of schema is used normally for sophisticated requirement and for aggregated for fact tables that are more complex to be supported in the star schema or Snowflake, if you will. This schema is very difficult to maintain due to its complexity. So so now we know when to use star and Snowflake and Galaxy. So that's when we can start designing our data modeling, right? But the thing is, we still have to care about the data distributions because you're dealing with a distributed system. So that's when we have to care about data partitioning. Whenever you send a request to Azure Synapse or the application or user, the control node receive that. The control node use or leverage massive parallel processing engine to distribute that data across all available nodes. So that's it. Under the hood, there's gonna be 60 storage or partition distribution, if you will. In my case, I have 4 compute nodes. That means each one will access 15 distributions. The more you increase it, the lesser distribution for each node to work on, and you're gonna get better performance. However, depending on your goal, if you wanna achieve query performance, so that's when you have to think of what to do. If your environment is, for example, 60 to 70% of batch processing, you have to think of what partition model should you use. If your environment is very like nightly job, weekly job is like 1 or 10%, and you most likely care about performance, you have to know what partition to use. How can we partition our data? Azure Synapse support 3 types of partitions. We have hash. Hash partition is that, for example, it will distribute your data across multiple nodes using a distribution colon. The SQL pool, for instance, use this colon to distribute the data across node, keeping all rows with the same value in the same node. This option delivers the highest performance for join and aggregate on large table. It is ideally for anything that is larger than 2 gigs. As you can see, when you create the table, you have to put a hash partition because the hash partition, it is optimized for query processing. So if you want to build your process based on performance, you have to think of hash, because the good thing is after your data being distributed, you're gonna have a distribution key return. So that's when you know exactly where your data reside. For round robin, it is the default one. So it's gonna go and distribute your data evenly across all 60 storage without any distribution key. It is optimized for batch processing. So if you have staging environment, you're loading, it's gonna load 1, 2, 3 because it doesn't care about the distribution key. Doesn't care about if the data are the same, let me add it to the same partition key, to the same distribution. So it doesn't care. All it cares about, do I have a space? And then the data being dumped. So that's been for batch processing, that's gonna be a great one. Replica, how does it work? Nowadays, storage is not that expensive. If you have any dimension table that is less, what would I say, than 2 gig, instead of using round robin or hash, I would highly suggest you to replicate it. How does it work? It's gonna go and replicate your whole table across 60 storage. If you're looking at date sometimes is hard to maintain. And then if you have a date table, dimension table that is not, for example, too large, you understand? You can think, for example, of replicating. But there is a downside. If you have a lot of DML, like update, insert, and delete, that is happening, you should not use replicated. The other thing you have to understand is that when it comes to hash 100% based on access pattern. Knowing how business will access that table, that data will help you define a better distribution key. And then look for something that does not have too much duplicate and then have fewer nulls. Otherwise, if you only partition your data, you may end up to have data skew, what we call a hard partition, where one partition have more data than the other. So that's mean there will be performance impact, and then you may end up to even pay more. It may impact costs. So this is it for, so now we're done with example, the data modeling. We know exactly how to partition it. We know, for example, if we have to partition it for performance, we have to use hash, and hash is based on access pattern. If we have to design our table for a staging or batch processing, we have to think of round robin, which is the default one. So now, when it comes to data, modern data processing architectural pattern, you have to think of two main things. There's another one which is Zeta. It is kind of new. Google talk about it a lot, but I don't have too much information. That's why I didn't update my slide deck. When we're looking at Lambda, Lambda is this architectural pattern is what will define your data pipeline. Okay, so if we're looking at Lambda care about all data. When you're looking at Lambda, you have to see complete data. You have to see the live streaming data multiplied by stored data. Whereas Kappa doesn't care about batch view. Kappa only care about the live data, and Kappa is a great candidate when it comes, for example, to online learner. We don't care about history data. We just need to collect the live information. That's it. If you, let's say, for example, if business want to do live analysis, when they receive the data live, they want to go against the data to do some analysis and dump it. That's when you have to think of Lambda. Lambda is most likely what everybody use and comes with two flavors. If you're looking at it, comes with what we call a Unifi serving layer, and it comes with two separate serving layers. As you can see, it is good for immutability of data denormalization, and pre-computed view. It has three layers. It has a batch layer, what we call code layer, code path, and then it has a speed layer, what we call hard path, any serving layer. Let's analyze both of them. If you're looking at the Unifi Architecture, this is the hat, this is the code. The hat is what we call the speed layer. That's the speed layer you see in millisecond, and the batch is what we call the code path. Okay, and it could be minutes and hours, if not days. Okay, so if you're looking at, they have one serving, the real time and the batch processing point to one serving. So for large enterprise that does not require downtime, if the serving is down, guess what happened? There is both services down. All your batch processes have to wait, and all your real time has to wait. So what they do for company that does not have does not allow downtime, okay, and then what they do, they would where they spend extra money and design this. And this is different from Kappa because you still have the batch layer, because Kappa does not deal with that. Just for your information, not to get confused. If you're looking at here, so now they separate real-time layer with what we call speed view, and then with the batch layer, what we call batch view. So that's mean all batch processing point to the batch view. Any mixed query point to both. All real-time point to speed view. So that's mean if batch is down, you still have things that live. If speed view is down, you still have things that live. So that's mean not your whole system is down. How can we build something like that using in Azure Data Factory? Using Azure, we can, for example, within Azure, this is, for example, if you're looking at that, Azure IoT Hub, and then this is event. I can clearly see this is streaming. So that streaming represents the speed layer. I can use Spark here to do the streaming processing and do machine learning, and then push the data to consumer with the help of service bus. And then I can get Data Factory as well to go and get the raw data and do all kind of processing and then store that data. So you can see we have these two. In the other end, Kappa doesn't care about live data. Sorry, batch view. Kappa only care about live data. If you're looking at this architecture, when you're designing your end-to-end data warehouse, you can see Kappa provide just a speed layer. And that speed layer is what analytic client will use. Under the hook, we have, for example, the master data. This is what I like about this. You can predefine your resources because you don't need to have a giant system to maintain this data pipeline, because you're dealing with live data. You're not dealing with massive data. You can define the memory, the CPU. Do you understand? The downside is if there's anything happen, you may need approval from manager or business to refresh it. And then when you're designing this kind of pipeline within your end-to-end data warehouse, it's easy, but maintaining, things, troubleshooting can make it a little bit complex. So if we have to design something like that, you can clearly see here is that they don't have the batch layer. They only have the speed layer, as you clearly can see here, right? So now, let's go to some live data. We already introduced, for example, Azure Synapse. Let's see, for example, what can we do? Give me a second. So we already introduced everything. If we have to load the data, how easy can you access it? For example, if I click on action, if I click on this guy, I can select, I can leverage the SQL pool to read data, for example, from Azure Synapse, from Azure Data Lake. As you can see, this is that in my data lake storage. You can see it is, for example, you leverage OpenWSET to access that data. I'm not sure why this is running slow. Okay, you guys get the point. So for some reason, this is running, so I'm not sure why. Okay, let's say if you want to connect to your SQL, to Azure, you want to create Azure Cosmos DB link, that's where you're gonna be. We spoke about this. Unfortunately, I have a couple scripts to run. Okay, let me execute this. Like that. Yep. Anyway, I don't want to spend too much time on this one. As you can see, I was able to query the data from my data lake, right? So the main thing is not really the lesson for my session is not really, for example, query the data. The lesson is most likely build your how can you build your end-to-end data warehouse, and then what would be the requirement. If I click, for example, here, as you can see, this is the same interface that if I want to create a new one, let me create a new one. If I want to create a new pipeline, I can quickly click here. Okay, I can see all kind of transformation. So if we're looking at for general, I didn't have home. So these are all the things you can do to design your pipeline, right? And then you can leverage HD inside as well. And then you can do so much stuff. For example, guys, it is rich, unlimited feature. So it's gonna be very kind of hard if you wanna ingest data from a different system not to be able to do it. I know there is a matter of time. I have 38 minutes, probably have 5 minutes left. Let me go back to my slide deck, and then so this way we can go, because designing a data warehouse, it's most likely based on the modeling, distribution, and the data processing. So Azure Synapse Analytic does not fit if you have, for example, 1 terabyte of data. So it fits for anything that is at least 5 terabyte to me, because there is a cost. So what should you use of Azure Synapse Analytic? For example, you have to think of batch processing, real-time processing of big data in motion, interactive exploration, predictive analytic, and machine learning. And then that's the only places I would highly suggest you to think of it, because there is a cost. There is a big cost, especially if you do not know what to do, because it's easy to go and build any data warehouse, but following the best practices is where things comes a little bit tricky. But yeah, I think that's it.